Okay, this is going to be just a video and to support those of you who may be having a hard time doing coordinate conversions or cross products or scalar products. When I say having a hard time, it means you're spending more time on the computations than on the power that exists in these computations. The power of working in standard engineering notation, or the power of doing cross products or dot products to do things such as calculate station offset, such as calculating down face on a 3D tin model. The mathematics is really not tough in doing these computations, but you can stumble over them as you're trying to do them with maybe a program that's on the internet or something else that you have to go to a computer to do. So we're going to look at how we're going to be using lists, and I'm going to introduce you to a couple of things if you don't know it already, and how to go about making lists. And we're going to reserve a few lists in our calculator. We'll be reserving the U and the V lists for our two vectors that we're going to multiply together. They will then be the multiplication, the cross product multiplication will then go in the W vector. So a couple of things you'll want to be able to do is to go ahead and actually use the editor so you can actually just see your output, or more or less just key in input for U and W, U and V, and then look at what comes out in W. So the first, if we're looking at a three-place list, the first, the second, and the third will be the X, the Y, and the Z position. If we're looking at a fourth position, that will be then the T, the time attached to that point. So how do we go about dealing with lists? Well, obviously, I think you've looked at them before. We turn on the calculator, we go to mode, we make sure that we have everything set correct, degree, and realistically we'll probably be just as often using parametrics as we will anything else. That float makes it a little bit easier to look at if we make it just 1 or 2, and then you can change it later. So we can hit second quit here. Now, lots of different things to do, but one thing we might want to do is just look at the lists that come in your calculator, might be sticking around. So list 1, 2, 3, 4, and that's basically the 6 or 10 lists that are defined. You can define a list, however, by using the dimension. And so right now, for instance, list 1, if we hit list 1 here and we enter it, list 1, it does not have actually any dimensions, so we're going to quit. So we're going to go ahead and, for instance, now just show how you can use 3 stow. I'm hitting a clear here. I'm going to hit enter and clear again. We're going to store 3 into second list, and have to go here to operations and look for the dimension one here. The dimension, we're going to store 3, make it the dimension or the length in terms of how long of a list it is for second list L1. What that just did is made L1, now if we look at stat edit here, we're going to see L1 has 3 places in it. So it actually has stored 3 places. Well, that's all well, fine and good. That might already come up in your calculator. Hit second quit here. But for instance, on a lot of these programs, we're going to be making a variable U, a list U, and so one of the variable statements, or the statements in the program, will be 3 stow into, again, second list operations, the dimension of, actually now in this case, second list, go to operations, the very bottom of that is L there, L alpha U. I'm sorry, alpha U. So that's going to make list U being 3 long. Same thing, 3 stow second list operations dimension of second list operations. It's the very bottom there is where you find that small L for the list, and then alpha V. And finally, 3 stow second list operations. You get a rhythm for this like a lot of other things. Second list operations, back down here, L, and then alpha W. So what we've just done is we've made list U, V, and W, and this is what's going on in the programs, but just realize that most of the inputs, the programs are going to store the first vector in LU, the second vector in LV, and the cross product will be stored in LW. This is going to be useful if in fact you want to go ahead and actually just input your own U and V and skip through part of the input on the vector program where it's asking you for input. That's pretty useful to start moving vectors around, and so we might want to make one final vector and call it LV1 like we do in some of these programs. So you can go 3 stow second list, stat second list operations dimension second list operations L. Now you'll see that you can actually add more than a couple of letters together in list. So we can here hit alpha V1 close parentheses. And so you have here, you have something stored in vector list V1 as well. Now if you go now and then set up now your editor to deal with these things, it makes it a little bit easier for later. You're not dealing in list 1, list 2, list 3, list 4. You're just dealing in U, V, W, and maybe V1. And V1 is going to be one of these we might use to force input to V1, force V1 into U, input V1, force V1 into V, and then multiply the two together to get list W. So you're kind of moving things around in a calculator, anticipating how this program structure has been done, and then hopefully starting to expand out and doing things yourself. I have included in this set a coordinate convert, a transformation, which is a little iffy, Bernoulli's equation calculator, a Manning's equation calculator, a vertical curve, a very rough vertical curve calculator. It's for you to kind of figure out how you can program and use some of the second order curve stuff so you can realize you are not learning things new each time you relearn a new application of a trigonometric function. So in this case, I'll show you finally how to set this thing up. I'm going to go up. I got to turn it back on. I am going to, at this point, go ahead and do stat, and I'm going to set up the editor, right? Second, I'm going to go stat. We're going to set up editor, set up the editor to do second list, list U, comma, second list, list V, comma, second list, list W, and then comma, second list, list V1. Hit the enter here. Now when I go into stat, edit, you see I've got U, V, W, and V1. So for instance, one thing we might do on a program might be have an input in the V1. That comes out of coordinate convert. It actually stores them in V1. So you might have 10, 3, and 5. You can hit second quit here. You can then do something like second list V1, stow it into second list U, and that will now put that in vector in list U, and you can do the same again for something else, and then you can finally eventually go through and use a program to force something into W. So that's kind of a real quick review. Dimension works also for matrices. We'll cover that when we cover matrices more. Start using these things on a regular basis. That will help you out to be very much more efficient and effective and a better civil engineer technician.